My name is Lane, and I'm the High School Tech Lab lead for our 2025 Summit. Today, I'm going to walk you through how to build a simple, light-following robot. This video will contain 3 main parts. I'll jump into a step-by-step walkthrough of the actual build. Next, we'll test out our robot, and finally, go over some common mistakes and troubleshooting. Just know that the goal isn't for you to become a robotics expert. It's simply to give you some hands-on practice so you feel prepared and confident supporting our students. So, let's get started. So let's start by checking your kit. Each kit will come in a bag like this, 1 kit per student, and 1 kit will make 1 light-falling robot. Each kit will contain the following items: 1 foam board square, so about 3 by 3 inches, that'll be our base, 2 to 3 pieces of double-sided foam tape, 2 yellow motors, 2 wheels, 1 battery holder that holds 2 AA batteries, a breadboard, 2 sets of resistors. 1 has green tape, 1 has blue tape. The tape is there to differentiate the 2 sets. 2 transistors. These will act as our automatic switches. 2 light sensors will act as our robot's eyes to sense changes in light. And finally, 2 jumper wires, 1 red and 1 black. You may be used to seeing jumper wires like this, where they're longer. These are the exact same, they're just extra short. Some items that aren't in the kit, but students will still need: 2 AA batteries to power our robot, a pair of scissors, and optional but might be helpful, electrical tape. Now, one quick note: when emptying your kit, some parts may stick to the motor. Double check in case you think you're missing something. If you do break or lose a part, don't worry, we'll have spares. Our build will happen in 2 sections. We'll start by building the foundation of our robot, and then once that's set, we'll assemble our circuits. Step 1, we'll start with our foundation. Grab your 3 by 3 foam board, your 2 motors, 1 piece of double-sided foam tape, and your scissors. As you follow along, assume that the front of the bot is facing away from you. So this will be our front of the robot, this will be the back of our robot. Position your 2 motors flush with the center edge of each side, wires both facing left, and the white pegs will overhang the sides. This is where the wheels will attach. Once you've positioned them like this, we'll go ahead and secure it. Cut your piece of foam tape in half. Maybe do one side first. The wires should face left. And then do the other side. Give that a squeeze. Try not to break it or bend it, that'll kind of make it wonky. So once the motors are secured, flip your base over so the motors are underneath. The wires should now be facing to the right. We'll now be working from a bird's eye view. So assembling the top of our base, go ahead and grab another piece of foam tape, battery pack with wires, and your breadboard. Attach battery pack first, place it in the center back of our robot. Our foam tape, none of this has to be perfect. Our wires are going to go to the right. Back center. Finally, we'll attach our breadboard, position it vertically, just look for this tab on the vertical side, and this is going to be our front. Notice that there's some letters up top and on the bottom, and then some numbers on the side. Go ahead and peel the adhesive backing from your breadboard. We're going to place it perpendicular to our battery pack. From above, it should look like a little upside down T. And with that, the base is done. So quick recap, we started with our motors, both wires facing left. The black part should be facing away from you. When you flip it over, the wires are now facing to the right. We also attached our battery holder, wires to the right, and our breadboard perpendicular with the little tab at the front. Now is the fun part. Let's start our circuits. So we'll start by giving our breadboard power. I don't recommend you insert your batteries until the very end or until testing. Just so I can show you in the video, I'll insert them now. If for whatever reason you do have them in, just make sure that this lever is disengaged. So make sure your battery pack lever is up. To keep it simple, I'm going to provide you with specific coordinates where each wire and each component will be plugged in. That's why I mentioned these letters and numbers. So even if you can't see these, you can count 1, 2, 3, 4, 5, 6, 7. There's 17 rows, and it's always going to be A, B, C, D, E, space, F, G, H, I, J. So even if you can't see it, just go through that process, and that will work just as well. I'll do my best to walk you through the logic, but know that you can always verify exactly where it needs to be placed with the coordinates I provide you. On our breadboard, we want to extend our positive and negative currents so we can plug in multiple things. This project, we're going to designate row 1 as our positive row to carry our positive current, and row 17, the very bottom row, as our negative current. Sometimes when you're dealing with electrical work, you might hear the term ground. All that means is the negative current. So this negative row would technically be our ground. Just to keep it as simple as possible, I'm only going to refer to it as positive and negative. So starting with the power source, since our battery wires are already on the right, we're just going to plug these into the right side. So our positive current will go into J1. Our negative current will go into J17. Every part needs to have electricity flowing in and out for it to work. So whether it's the motor, a switch, or light sensor, each will somehow connect both to the power, the positive, and the negative. So with that, our currents are now flowing through the red wire into J and all the way to F. The gap here doesn't let power flow all the way through. So to do that, let's extend our current path all the way across to the left half, almost like building an overpass. So we'll grab our jumper wires and we'll go ahead and insert it into our breadboard. I'm using tweezers so you can easily see what I'm doing. You'll notice that these wires are just a touch wider than the breadboard. These should be a perfect fit. Squeeze them together just a touch to make a 90-degree angle. They should fit in perfectly. So for our red jumper wire, we're going to connect it to E1 and F1, and the black jumper wire, and that'll go into E17 and F17. So anything we plug into this row will have the positive current flowing, and same with the negative row. So since our robot has two independent motors, we'll have two separate circuits, one to power the left motor and one to power the right. We'll start with the left circuit, and then you'll duplicate it on the right. Each motor circuit will have these components: a light sensor, one blue resistor, one green resistor, and a switch. They're a little tangled up here, but locate the red wire for your left motor. So insert the red wire into B1, the positive row. Go ahead and keep the black wire unplugged for now. Next, we'll connect our light sensor. This will behave almost like eyes to be able to look for light. One leg will go into D1, the other leg will go into D6. It's okay if the legs bend a little bit. Now, we need to complete our loop and connect it back to our negative row. So right now it's currently in our positive row, but in order to complete the circuit, we'll need to make sure that it gets connected to the negative row. And I'll refer to this row as a junction, which basically means a row where multiple things are plugged in. So to complete this connection, we'll just need to add a path from our light sensor back to our negative row. We're going to use the green resistor, or the more powerful resistor. Just pull the resistor out from the tape and it should just slide out. It's okay if it bends. Connect it into B6, which is our junction row where multiple connections will take place. And we're going to stretch it all the way to B17, back to the negative row, completing the circuit. Next, let's add our automatic switch. Remember, it has a little half moon shape going right to left, and you can spread these pins out. So the right leg will go in C17, which is the negative row, the middle in C15, and the left leg in C13. Easiest way to do this, start from the negative and do one pin at a time. And it's okay if they bend a little bit. So when you're done, the flat side should be facing to the right in row 17, 15, and 13. Now our blue resistor is our last additional component for this side. This will carry the signal from our light sensor to our automatic switch. So if you remove the blue resistor, again, it's okay if it bends, we're gonna place it first in E6 next to our light sensor and into E15. So right next to the middle pin on our switch. Lastly, our black motor wire. So this we're going to connect into A13, which is in line with the top pin of our switch. So quick note, you may be asking why we don't directly plug this into the negative row. Since all the red wires went into the positive row, why don't all the black wires go into the negative row? Well, I'll show you why. So if I activate our battery, and if I add a wheel so you can easily see what's happening, if I plug it into the negative, it works, but it won't listen to the light sensor. So in order for it to only turn on when the light sensor tells it to, we need to instead connect it to our switch or our transistor. So now if you flash your light, the wheel will run. Quick recap, our battery sends electricity through our top row, our positive row, sends a current through the motor, back around through the black wire, eventually returning to the battery. Also sends a current through the light sensor, activating it. So now this light sensor is constantly looking for light. That current splits off into one resistor, which returns to the negative row, completing the circuit. The other travels to the switch, sending a signal whether or not to turn the motor on. And that switch sends that signal to that motor. So now the hardest part is over. We're just gonna repeat exactly what we did on the left side with the right. So this side I'll do a little faster, but I'll still tell you exactly where everything needs to go. So let's go ahead and do the right side. We'll do it in the same order as we did last time. We'll do our red motor wire in I1, our light sensor connected to the power at H1 and H6 into our junction row. Our two resistors, so our green resistor, we'll connect back to the negative row. We'll put it in I6, stretch it all the way back to the negative row. So I6 to I17. Then our switch or transistor. Check the orientation. It will face the same exact way as before. I know you might be tempted to mirror it, but it won't work if you mirror it. The flat side should still be facing to the right, and we'll do the same, except this time in column H, H17, H15, and H13. Our last piece, the blue resistor, will go in F6, so our junction, our right junction, to the middle leg of our switch, which is F15, so in line with that middle pin. And last but not least, the only motor wire left, our right black motor wire, will go opposite of the other black motor wire into J13. I like to loop it around the back. Beautiful. So both motors will activate when our robot sees a bright light, but before we call it a day, let's pause and turn on the flashlight. Obviously I have a bright light going, so it continues to run even after I've stopped activating it. But if I cover it, it'll stop. But if I activate the right sensor, it activates the right wheel. Same with the left. So if I activate the left sensor, it activates the left wheel. Now this iteration works, but our robot is set up to actually run away from the light. To make it follow the light, we want our sensors to actually signal the opposite motor. So this is a super simple fix, but I wanted to demonstrate kind of the logic behind how this robot actually works. So to make it follow the light, we want our sensor to signal the opposite motor. Since our black wire is receiving the on-off signal from our switch, all we have to do is swap the black wires on either motor. So the right sensor controls the left motor and the left sensor controls the right motor. So let's go ahead and do that now. So if I take out one motor wire and replace it, it's going to go in line with our switch, otherwise known as A13 and J13. So row 13 on either side. And I've now crossed it. So before we test it, let me tell you how it's supposed to work. If only our left sensor sees the bright light from the flashlight, the right motor should be activated and it should turn towards the light. Likewise, if our right sensor sees the light, it should signal the left motor steering the robot to the right. If both sides see the light, then the robot should drive straight ahead. So let's test it out. So you'll notice how my robot actually dragged to the right. These wires can sometimes get caught in the wheels. So this would be a good example of trying to use the tape to kind of clean up some of the wires. Let's talk about troubleshooting. First things first, our battery holders have a switch of their own. So make sure to engage that, otherwise nothing will work. Just remember before you're done with it to disengage it. You don't want this continually running. Another potential mishap, if the motors are too far back, that can sometimes leave too much space, which can lead to dragging. If something isn't working, I would recommend double checking the coordinates. Common mistakes are the placement of the black wire. Second, there might be a cross wire. So if two resistors are touching, the metal parts are touching, the blue parts should be fine. But in some cases, depending on how wonky the resistors get, sometimes the metal pieces will actually touch. So spread those out, make sure those aren't touching. The other thing is our transistor. Make sure that the flat side of our switch, our transistor, is facing to the right on both sides. We're not going to mirror it. And there you go. You now have a fully functioning light following robot. Remember, the goal isn't perfection. Focus on keeping the students engaged, encouraging collaboration, and celebrating their progress. No matter how fast or slow it comes together, you help set the tone of the day by creating a safe space where students feel comfortable asking questions, seeking help, and working with their friends. I hope you take the time to build one on your own or with a partner, and don't hesitate to reach out if you have any questions. I appreciate you staying here through the whole thing, and I can't wait to see your robots in action at the summit. Good luck!